Great, great. I think there was some problem with my mic. Are you able to hear me now? Is the voice clear? Raghav, George, Abhishek, Ashish, Krishna, Manjunath, Sangeeta, Hardik, Avinati, Sri, Samiran, Utkarsh, Rathina. Hi, Aman. Hello, Namita, Hardik, Shruti, Ashish. Session we are about to start in a couple of minutes. Alright, we are starting in 1 minute. Feel free to ask questions using the live chat. Alright, alright. Okay, and keep in mind that the course that we've launched this AI for the deep learning specialization is running is feeling very fast. So either you enroll now or you can enroll for the next batch. All right, great. Let's get started with today's session. It's very wonderful to have all of you in the session. You all are from very great backgrounds, and feel free to ask questions using the live chat. And these sessions are known for their audience. The audience is from all across the globe, and in the last session, in the last similar session, we had more than 2,000 people concurrently watching, and total views in two hours were more than 5.5 thousand. All right, so great, great. All right, so the session is about the careers in AI and machine learning, and this is specifically for the course Deep Learning Specialization, but we will also talk about other courses that we offer or the other courses that are suitable for you. All right, now moving ahead. All right, so today's agenda is that we will be introducing two parts. One, we will be helping you understanding the AI landscape as well as the careers or various kinds of jobs available in the AI and machine learning and in general computing. In the current era, what are the various kinds of jobs that are in demand? All right, so that is the agenda for today. So the agenda, we will start with the introduction of CloudxLab. What is CloudxLab? Then we will talk about who are the authors, instructors, and then we will talk a bit about IIT Roorkee. Then we will talk about what exactly is machine learning by the way of a couple of examples by showing you Mario example. After that, we will talk about AI, that how AI is different from machine learning. Then we'll talk about why machine learning and AI is so important today. Then we will talk about the different ways of solving problems when we talk about machine learning. So we'll talk about what is so different about machine learning approach to solving a problem. And afterwards, we will talk about various career paths and job statistics. Then we will present you the courses that we offer, and then we will answer the frequently asked questions, as well as we will answer your questions by the way of voice. So today is 24th May and the session started at 8 p.m. and this is going to be a 2-hour session with 10 minutes break in midway. Except for myself, everybody is on mute. So please use YouTube's comments to ask questions. My team, Saurabh, Praveen, and Abhinav and others will be available along with me to answer your questions. All right. So we all are available on the live chat to answer your questions, and I will be answering your questions towards the end of the session. The recording of this video as well as slide will be shared after the session, and the recording will anyway be available on the YouTube publicly, and the slide will be mailed to you as well as updated. The slides link will be posted in the YouTube video description after this. Also, If you have not already RSVP'd, please RSVP to this event so that we can send you the slides and other goodies that we give in this session. So you can take a look at cloudxlab.com and cloudxlab.com for more information. So let's get started with the remaining chapter. So we are going to start with the with the about CloudxLab part. About CloudxLab, at CloudxLab we are building a platform where we are upskilling engineers and professionals. Now the unique part about CloudxLab is its playground for hands-on, whereby there is a problem statement on the left hand side. On the right hand side you will get a Jupyter notebook, the standard environment that you will use in production as well. If you go and work elsewhere, you will be familiar with that environment, because Jupyter is widely used in the world in case of machine learning, statistics and everything. Alright, therefore we have kept the playground as is and we have built our own evaluation on top of it. So on the left hand side you will see a small problem statement. You have to solve it in the right hand side and then you submit, and it'll check your work and quickly answer whether you're doing good or not. This is how a cloud-based lab looks like. This is the terminal where everybody logs in and people basically can do anything they want in the lab. On the cloud-based lab, which is very unique about CloudxLab, because we provide you a full environment whereby you will get the real-world experience, a seamless experience, as in you don't have to download, install anything. Everything is available, including the datasets are available in the lab. Similarly, the lab or the terminal or Jupyter notebook can be connected from any browser, SSH or any operating system. The other part about CloudxLab is that we are basically focusing more and more on social. Learning that's not shared is not fun at all, and the more you share your learning, the more you will learn. And that's the reason why lots and lots of people actually communicate and collaborate at CloudxLab. So you would see that there are lots of people, many people are concurrently learning with us and actually helping each other. Also, there is a social proof that you have completed these topics and so on. And there is a very vibrant forum in which people keeps on asking all kinds of questions, and we as well as other users answer them. Also, we have hiring partners. We keep on sending emails as well as keep on sending the job updates to all the learners. And regarding the instructors, I'm Sandeep Giri, and I'm the founder of CloudxLab. And I started my career long back in 2002. I'm an alumnus of IIT Roorkee. So I started my career with D.E. Shaw. At D.E. Shaw, we did lots of distributed computing. And after D.E. Shaw, I founded a company called T-Bits Global. At T-Bits Global, we built the software to manage the documents for power plants. Most of the power plants have been constructed using our software in India. And after T-Bits Global, I joined InMobi, where I built a recommendation engine churning around 200 terabyte data. And afterwards, I joined Amazon. Amazon detail page for the mobile is what I built at Amazon. The other authors for this presentation are Praveen and Abhinav. Praveen comes with a very great experience with semiconductor industry as well as a lot of AI and machine learning. And Abhinav also comes with lots of strong computing background, worked with Byju's and Hashcube, and has a wonderful experience in the technology industry. So Great. A brief about our collaboration with IIT Roorkee. So IIT Roorkee is the oldest and one of the pioneers of the technology in Asia. It was it was established more than 160 years ago, and it was a civil engineering institution established by Britishers long back, which was converted into University of Roorkee and then IIT Roorkee. So IIT Roorkee has partnered with CloudxLab to provide the, the executive courses to the global audience. And CloudxLab is serving as a platform for IIT Roorkee courses. That's about the collaboration with IIT Roorkee and CloudxLab. All right, great. Let's get started with the fundamental question that what exactly is machine learning. So instead of just talking about the careers, what we're going to do is we're going to first learn what exactly is machine learning AI so that we know what we are talking about. All right, we know what we're talking about, and then we will be able to connect the dots, and hence we'll be able to figure out which job options are great and which which career options are more suitable to you. All right, so let me get started with a simple question, that what exactly is machine learning. Okay, so in very academic terms, machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. All right, now this seems to be, something that doesn't settle, right? So I'm going to give you more and more details about what exactly is machine learning. All right, let's take a real world example of what exactly is machine learning. All right, so you all must have heard or played a game called Mario, right? Most of you must have played the game called Mario. And in this game called Mario, you in the end win the princess. Do you think that the computer can learn and play by itself? Do you think that the computer can learn the game and play by itself? All right. So the way it was done, I'm going to walk you through a video whereby the computer learns to play Mario. So it was automated, as in the computer was hooked to the game, and the program learns to play Mario by pressing the keys and observing the screen. So it presses the keys, observes what's going on the screen, and then tries to maximize the score. So let's go about it. So here we go. I hope you are able to see my screen. So here, this is the day 0, and the computer is pressing the keys randomly, or the program is pressing the keys randomly and dies of old age because it's not going anywhere. It's more like toddler, it's not going anywhere. Few more weeks of playing over and over, is playing a little better, you see? It's playing a little better. It's able to walk few frames in the future. Now, few more weeks and it's almost there. It's better than me right now. You can see here, it's able to play very well. Now it's having these intuitions as well of these heights, and you can see it is able to play very well without any problems. It has basically learned to play Mario. Do you think he'll cross it? I think he will. Yes. All right. Now you can see he's having no problem at all, and it's playing it perfectly. It's playing it perfectly. Now it's more than expert. Now it's better than me. After this point of time, you'll see this. It's just amazing to see this. you will see it exploiting a bug that nobody knew it existed. When the Goomba is falling on it, so what was that? What was that? So when the Goomba is falling on it, it starts moving downwards and there. So it figured out a bug in the game. So since machine was playing, the computer program was playing over and over, it figured out how to hack into it. Now you will see the program exploiting another bug. I have no idea how does he do that. See that? Alright. Now, the same program was hooked to other games and you will see that when it was not able to win, what it kept on doing is it kept on pausing the game. It kept on pausing the game when it could not win the game. So now this is machine learning. A machine which kept on playing the game, and by pressing the keys and observing the screen, it learned how to play. It learned how to maximize the score. It learned its own ways. Nobody taught the program what is gravity, what is colliding, what is Goomba, and what exactly is or any other thing. The computer learned by itself, by observing the data, by observing what's going on in this environment. And that's exactly what is machine learning. Machine learning is, now if you go back to what we were talking about here, it will make more sense. Let me go back. It's a field of study that gives computer the ability to learn without being explicitly programmed. Do you see that? So now this sentence will make more sense to you. Moving ahead, so machine learning is essentially letting the computer figure out what exactly are the ways to predict the future. All right. Now that was what we just saw. The program learned to play Mario and other games without any programming. And yes, in this course that we are going to talk about, the IIT Roorkee course, we will learn to automate playing the game in a topic called reinforcement learning. This form of learning is called reinforcement learning or reinforcement machine learning. All right, we will learn it towards the end. I think it's third last chapter in the deep learning course. All right, so basically this is something a very good way to understand what is machine learning. Machine learning is that branch of computing which deals with learning from the data or teaching the computers to learn from the data. All right, now the next question is AI. You must have heard AI and ML interchangeably. Long back in 1956, the term artificial intelligence was coined by John McCarthy in Dartmouth College in New Hampshire. Now, to further elaborate the meaning of AI, John McCarthy defined sub-objectives which describe intelligent machines. So, AI is not a tool, though it's used like supposed to be. AI is an objective. AI is an objective if something is artificial intelligence. All right. So AI is an objective. There are 5 sub-objectives. To achieve AI, we need to achieve these 5 sub-objectives. First one is we should be able to represent knowledge, build a perception, the understanding of what it sees. Third is the reasoning. Fourth is navigation. And fifth is natural language processing. So if a robot can show these 5 characteristics or a robot can meet these 5 sub-objectives, we call it artificially intelligent machine. Alright, so that's how it is. So AI is more of an objective. AI is more of an object. Machine learning is one of the tools to achieve that AI. Alright, now let's go back to how to achieve AI. Objective, software such as machine learning and deep learning, the software packages, or you can say software techniques and tools, along are the ways to achieve AI. So AI is an objective, it can be achieved, and it is generally achieved by a combination of hardware and software. Under software, there could be two kinds of things. The first one is the rule-based programming, the way we have been doing the programming, like we inferring the rule and coding those rules. And second one is the machine learning, the way we saw the Mario example, whereby we saw that machine learned from the data. So those rules for playing the game were not written by people. It were inferred by the software. And that's what is machine learning. And a subdomain of machine learning is called deep learning. Deep learning are those complex algorithms which is basically designed to make which have shown very great results with respect to the prediction or with respect to machine learning, right? So deep learning is part of machine learning, or you can say deep learning is a subset of machine learning tools which are used for achieving AI. Alright, so this is how we see it. AI is an objective. Using software and hardware, we try to achieve it, right? And there are other use cases of machine learning other than AI, and there are other use cases of deep learning other than AI. Okay, so you will see that further. Like for example, one of the projects that I am working on with is with one of the institution whereby they're trying to invent a material and other things using the photos of the crystal. So they are trying to predict whether a particular material is sustainable or not. So that's how the material invention happened in new era, that you synthesize a hypothetical crystal and then observe its strength, or you predict its strength on the room temperature. And that's how it is. So even though that project might not seem like AI, but it is using machine learning and deep learning tools. Alright, that's why you will see the circle not completely inside the bigger circle. So deep learning and machine learning are used for AI, but are not only used for AI. Alright, now there's something very important that I want to convey today. This is something very, very important that I want to convey today. Every industry you think is actually trying to predict something. Trying to predict something either based on their given parameters or based on hypothetical parameters. Every industry is trying to predict something. Let me take an example. For example, manufacturing industry is trying to predict which products to manufacture, which process optimizations to be done, and what price of the product to be kept. So all of this, and more than this actually. So manufacturing industry is trying to predict many things, right? Similarly, agriculture industry is trying to predict which crops to grow, what would be the price of produce, and what processes to follow to grow something. So it's trying to predict those processes. It's trying to predict the industry, or the various teams at these companies are trying to predict what prices of the produce they should keep, as well as what crops can be grown in what kind of environment. So all of this is prediction. All of this is prediction. All right. Similarly, the third example I'm taking is of healthcare. Healthcare industry is trying to predict the disease based on the symptoms. Which drugs are effective for a particular disease? It's trying to predict how can a pandemic be stopped. Healthcare industry is trying to predict which operating procedures are most effective for a particular disease. So healthcare industry is also trying to predict. So almost every industry that you see on the planet, every industry is trying to predict. Therefore, prediction is the key part in every industry today. Prediction is the key part in the industry today. And so every industry is trying to predict something, trying to predict something. And this is not new. This has been going on for many years, right? For thousands and thousands of years that has been going on. But what has changed now? What exactly has changed now? Earlier, the people used to come up with this mental model of predicting whether something tastes good or something, so humans used to come up with rules by themselves. Now, people use computers and machine learning in order to predict. Right? So human uses computers and machine learning to predict. That's the difference today. That's the difference today. Earlier, the rules were written by people. Now those rules are written by the computers and machine learning and by the aid of people. Let me take an example, a better example of the difference in approach. So it's a very important point that I'm trying to make. I'm trying to make a point that earlier people used to write these rules. Now it's the machines that create those rules based on the historical data. Based on the data, machines come up with those rules. Now, let's take an example of spam filter. How many of you know what is a spam filter? I know most of you do. And in the spam filter, what exactly happens? A spam filter basically takes an incoming email and marks it as spam or not spam. Sometimes not spam is also called ham. So basically, there are two different approaches to write the spam filter. One is this traditional approach. The traditional approach is that the scientists or engineers would sit at the problem, study like credit card, free, amazing in the subject. They are generally spam. So people figured it out. And they also figured it out when the email is coming from abc@xyz.com or webmaster@mysite.com. Those are generally spam. Now, they write these rules that when the subject contains these keywords, it's a spam. When the sender is any of these email addresses, is a spam, right? Now, this is classic way of solving problem. And once we have written the rules, we evaluate how good are our rules, and if they are good, we launch them. How do we check those rules? By comparing it with unseen data and the data on which we have not written the rules. If it's working well, we launch. Otherwise we go back to studying the problem, analyzing the errors, right? So this is the traditional method, and so we end up writing lots of rules and then we evaluate and launch. Now, do you see any problems with the traditional approach? Do you see any problems with this traditional approach? All right, so I took a brief pause. So the problem with the traditional approach is that we end up with just too many rules, and too many rules to manage and update. Second is that when those keyword that we have put on in the rules, when the spammers come to know about those keywords, let's say they figured out that the keyword amazing is marked as spam, so they will instead use other keywords such as fantastic. And this will be a never-ending war. You will continue to keep updating the rules, and the spammers will keep on figuring out which rules you are creating. And this way, this never-ending war will lead to complex systems and essentially ineffective system. Therefore, the newer approach is the machine learning approach. The machine learning approach basically is this. People study the problem, then we take the historical data and feed it to the ML algorithms. Then whatever mental model ML algorithms have prepared, we evaluate its results. We evaluate whether that model is working well or not. If it's working well, we launch it. If it's not, we go back to studying the problem. And this way you will see that the training here is being done, or learning or inferring the rules is being done by the machine. The machine is the one who is doing this analysis, right? And as and when or at certain frequency, this mental model of the machine that you see here will be updated. You can see the difference here, right? This is the traditional approach that we study the problem, we write the rules, and then we evaluate. Here, clever lots of clever insights that people won't be able to figure out will come into these ML algorithms. Just like if there is a person who is looking at a spam, they can quickly figure out that, oh, this is spam. In the similar way, the ML algorithm, the machine learning algorithms, will figure out whether something is a spam or not a spam. All right. Now here a very important part. Instead of being written by people, are being written by the machine. Let's move ahead. Now, these are the three messages that I want to convey. Let me repeat whatever I said so far. Every industry's prime objective is to predict something or do the prediction of some kind, right? Every industry's prime objective is to do some kind of prediction. Earlier, people or human used to come up with a model, a mental model to predict something. Now, human teaches computers to predict. Whether figuring out whether the printing has been properly done or not, whether a particular photo has been taken properly or not, all of these activities can be taught to computers. Therefore, machine learning becomes the main ingredients or main component or tool or technology for almost every company. So machine learning will be the main work of every industry. And it is already. The way computing ate up most of the jobs, machine learning will also eat up most of the jobs. So those who know machine learning will be able to command the computer, train the computer on the data, as well as will know how to build a machine learning project, and therefore such engineers will be high in demand. All right, great, great. There are a couple of questions that I would like to take right now, and then we will continue with our remaining discussion. All right. So one of the questions that is coming up over and over is that, again, there will be no certification for the webinar. The webinar is basically on the career, and therefore it's not possible to provide a certificate for this. Second question that is coming up over and over again is linear algebra required for IIT Roorkee course? So it is required in bits and pieces, and I would say that even though it will be taught in the class, but there is a self-paced chapter provided to you on how to process the data with NumPy and Pandas. Please go through that before the IIT Roorkee course starts. Okay, so you will learn most of the linear algebra as part of normal engineering, rather than looking at it as a very theoretical subject. The way we have tackled it is in a more practical sense. All right. So there is a chapter on NumPy and Pandas that is provided to everyone. Even though we will do a quick refresher, but it is strongly recommended that that you go through the self-paced portion that have been provided to you. All right. If you have already enrolled, you will see that those couple of chapters are provided to you already in the self-paced model. Please go through those before the course starts. All right. Now, question from somebody is how the courses are different than that of Coursera, edX. Are the programs designed to use the already built-in library, or can the learners create their libraries? Okay, good question. So one of the questions is that how are these courses different, which the CloudxLab has launched? So one of the things that is different is that we are taking more practical approach. Practical approach in the sense that instead of teaching you something old, we are teaching something really, really new, something that will be used in the future as well as today. Like, for example, in this particular course, we are going to use TensorFlow 2, that is the Keras API. Also, we will cover one chapter with TensorFlow 1, and also the whole course is in Python, and the analysis is using NumPy and Pandas, as well as the plotting of various graphs and chart will be done using Matplotlib. Also, this course is extremely hands-on. Extremely hands-on, as in the instructor in the class will code along with you. And this course has been known for being very hands-on. Also, lots of exercises are built around auto assessment engine, which means that you will get quick nudges when you are learning in the environment. So in the beginning, you will find it little hard on you, because it'll make you do things in the real environment. But towards the end, when you cross a certain threshold, you will actually start liking. Also, this course is live as in its instructor delivered, and you will be able to discuss a particular problem in details with the instructor. All right, that is something that is unique about these courses. The IIT Roorkee course is not a recorded one. Only the basics are recorded. The basics of machine learning as well as basics of data analysis is recorded. Remaining part is not recorded. Remaining part will be delivered live, as well as the recordings of the same will be provided to you all. So this course is again, this course will be co-delivered by IIT Roorkee, their professors, and so it has a perfect balance of the science and the technology, and and therefore these courses are extremely different from what you see online. And if the lockdown gets over, we might have the certificate ceremony in the IIT Roorkee campus, and that will be added advantage. So also, other than this, we are working with multiple the hiring partners, and we ensure that almost everybody who finishes our course would be getting job offers. And in the past, that has been the case. Most of the learners from CloudxLab have been extremely successful in their career. If you do not believe me, just go to LinkedIn, search for CloudxLab, and there will be lots of people you will find who have displayed this certificate, and they are well placed already. Okay, so this you can check everywhere. So coming back to it, we are way different from what you see at other platforms. Okay, so I'll take a few more questions and then we'll call for a break, and then we will go into more details about the career. Okay, okay. Let me carry on with couple of more slides, and then I'll take few more questions and then take a break. Okay. All right. Let me also talk about a path in machine learning that is generally followed. Okay, so far the points that I made is that every industry is doing prediction of some kind, right? Earlier earlier people used to come up with the rules. Now the computers come up with the rules. So the machine learning will be the main work in every industry. Okay, so why I've kept this is for the reason, very good reason. You might be seeing and talking about, tell us 5 use cases of AI or machine learning, this, that. Trust me, there are infinitely many use cases of AI, and almost everything that we do is some form of prediction. All right? So the use cases of AI and machine learning are infinite. It's up to us how creative can we get. All right. Now you will see this this question over and over, and I'm kind of done with this question. You might have seen me at the LinkedIn saying that these are the 5 good use cases I came to know. No, instead of just talking about use cases, if you understand the underneath technology, if you understand what's going on underneath, you will be able to come up with new use cases. Nobody had thought about the use cases like face synthesis that happened recently, right? Everybody talked about self-driving car, but things like face synthesis, video editing, they happened recently, right? So there are many use cases that you yourself will come up with when you understand the concepts, when you understand the technology, what it can achieve, and so on. Okay, like for example, noise removal from an audio is a machine learning task, and we are using it. Similarly, lots of other use cases every day come up. Coming back to, let's talk about a typical workflow of a machine learning project. Okay, this should cover most of the idea about the software industry. All right. A typical workflow of a software project goes like this. The first part is gathering data, using sensors, using other means of data acquisition. We gather data, and this gathering data happens in the larger databases, NoSQLs and HBase and HDFS and Kafka. This part involves IoT as well as big data engineering. Then comes the basic ETL. We call it extract, transform, and load. Here, we convert this raw data into something more meaningful using a cleaning process. The cleaning process, if the data is big, then we use Spark, MapReduce, or Informatica, or we can also use SQL. So this is part of data engineering or big data engineering. Then comes the basic analysis. You could use the same tools like MapReduce or Spark SQL or Hive. These are the various tools. So basic analysis involves taking the raw data or some semi-structured data and coming up with some analysis, right? This is the third phase. The fourth part is that using machine learning algorithms, we come up with the predictions and do far more detailed analysis of the data, or you can say predictive analytics of the data. Afterwards, we further optimize our ML algorithm for a particular problem or particular use case. For that, and come up with far more detailed plan for machine learning. If the data is big or the data is complex, then we can't really use the standard libraries. Then we have to go for deep learning techniques. So you can say that this part is classic machine learning algorithms using them. This one is deep learning along with understanding how to optimize an algorithm. Then once you are done with training a model or coming up with the mental model, then we take that model and put it into production. This phase involves DevOps. Hi, so let me try to fix the audio a little bit. Okay, let me just for a moment unshare my screen and let me try to increase the volume if I can. Okay, so okay, all right, just trying to increase the volume. Okay. Okay. All right. So let's try it out. I hope the volume will be perfect now. All right. So this phase that you see here is the DevOps. This one is the machine learning and deep learning. This one is applied machine learning that you are just using out of the box algorithms. And then this one is the basic analysis, the big data engineering analysis, data analysis, and then applying machine learning algorithms, say AI engineers and others, and then machine learning researchers and the scientists as well as the deep learning engineers here. And here are the app developers, DevOps people, and the other backend engineers or full stack engineers, they play a big role here. All right. So this is a typical workflow. This workflow could be different for different people. There would be tweaks and there will be deviations in this workflow. But this example workflow generally suffices to most of the things that you will do in the industry. All right. So let me take a couple of questions and then we will move forward. There are more things coming up. All right. Great. Wonderful to see that around 300 people are online. Feel free to ask your question on using the live chat. A question from Nikita is that how can one use AI and machine learning in urbanization without falling out nearby nature? Right? It's a very good question. Very good question. So it's a very good question because here what you have to do is you have to study the problem really well, understand how you can break down the problem into parts, and see if you can utilize the machine learning in predicting something. Say for example, people realize that they wanted to conduct a study whether bees are leaving a particular place or not. Now they basically built a simple bees counter using the machine learning tools, and they figured out that these many bees are going out and coming in. That shows the ecological balance in this environment. And similarly, when you look at a problem, you look at it closely and you will be able to apply machine learning and so on. The problem statement that you have asked is a way bigger problem statement. You will have to look at the problem closely and pick a small segment and try to see if you can improve that part. All right. And this is exactly what engineers are supposed to be doing. They'll study problem and figure out how we can apply machine learning in this. So once you have good understanding of tools, good understanding of technology, when you look at the problem statement, you will be able to figure out how to apply machine learning or deep learning in that problem statement. All right. Wonderful questions and great. A question that is coming up over and over is the next question is that there is an IIT Roorkee course that we have launched recently. It's basically deep learning specialization. It's a deep learning specialization, and in this deep learning specialization, we are cover what is required to learn the deep learning ideas, right? Like for example, we will cover what is the standard gradient descent and so on. So in case of the deep learning specialization course with the IIT Roorkee, we will be covering the deep learning, and before getting into deep learning, we will in first three sessions or first three chapters, we are going to cover the foundations of machine learning. Okay. Now, the prerequisites for that course is that you should be having an interest in computer science. Also, you should be having a graduate degree in science or technology, or should be pursuing one of such degrees. Okay, and once you enroll for the course, you will get you will get the self-paced course on Python, NumPy and Pandas. That those you have to finish along with the Linux course. Those are self-paced course. So it is generally better that you enroll for this course at least 1 week earlier so that you can finish the self-paced portion like Linux and Python and a chapter on Git as well as a chapter on NumPy and Pandas. These will be something that you will have to finish by yourself. And when we start in the deep learning specialization course, we will assume that you know Python and other parts. Also, in case there are concepts that are hard even in Python, we would basically do a quick brush up, but we will assume that you are comfortable with the basic programming language such as Python, right? You're comfortable for the comfortable with the the certificate. Sorry, you're comfortable with the Linux and Python. Those are the concepts that we would assume that you are comfortable with. So I'm talking about the deep learning specialization course. Okay, if the lockdown gets over, we would basically invite you to the IIT Roorkee campus, either in Noida or in Roorkee. Uh, Otherwise, the soft copy will be provided online anyway. For the hard copy, we will have the ceremony in one of the campuses. All right, so great, wonderful to have all of you back, and I'm seeing that around 460 people, 450 people are in the webinar. Hi everyone. So we will take 10 minutes break from here. So we will take 10 minutes break from here. So we will take 10 minutes break from here. All right. So great. Wonderful to have all of you here. Right now it's 8:58. We will be back by 9:08. All right. Break for 10 minutes. Back by 9:08 p.m. IST. Sorry about the echo because I'm also hearing my talk on a speaker as well as there is a mic and so on. So, okay, right, there was some echo because of multiple devices. So we'll take a break for 10 minutes and we'll be back by 9:08. You can also take a break. All right. I'll just leave it here. All right, so welcome back to the session. I hope everybody is back. So let's get started now. Thank you. Amazing. Amazing to have so many people attending this. Looks like the audio is not going through fine. Let me try to fix the audio, and I'll break for 10 seconds, and then we will be back. Thank you. All right, let's give it a shot. I have so many people attending this, and wonderful. Before the break, let me just summarize what we have talked about so far, so that we don't lose the context. So So we talked about what is CloudxLab, and we provide the environment and so on. We also talked about the authors. We also talked about our relationship with IIT Roorkee. IIT Roorkee is one of the premier institutions in India, those who are not knowing. Then we talked about what is machine learning. Machine learning is essentially making machine learn based on the historical data. And we took an example of Mario. And then we talked about AI. AI is more like an objective, it's not a tool. And AI is basically like an objective, and machine learning and the standard rule-based programming and hardware are basically the tools or technologies to solve or achieve AI. Now, one important point that I made is that every industry is trying to predict, whether manufacturing, agriculture, or healthcare, or any industry for that matter, is predicting something or trying to predict something. So the main change that has happened is that instead of people coming up with this mental model or the rules, or people figuring out the 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 so-called the insights, the people are now using computers to infer the insights so that it can predict better. Now, we took an example of spam filter. The difference in the two approaches was, in one, people were writing the rules. In the other, the machines were writing the rules. The computer was creating its own rules, right, based on the data. And this one has been found much more effective than the one in which the people were writing the rules. All right. So we talked about that every industry's prime objective is prediction, and earlier it was people who were creating those mental models to do the prediction. Now people are teaching machines based on the data so that machine can predict, right? Therefore, the machine learning, which deals with the art of teaching computers to predict, that machine learning will be the main work of every industry, right? Say you go to industry, you will have to understand the domain, you have to come up with the points where you need predictions, where all you are gathering data, and then you will have to utilize the algorithms of machine learning in order to do the prediction. So it's very important to understand how to use machine learning, where to use it, and in case you are using machine learning, how to further improve it. Okay. All right. Now the next thing we talked just before the break was that typical machine learning project follows this pattern. Okay, follows this pattern. We basically first gather the data from sensors, from the various places. This involves generally, sometimes it involves IoT and sometimes it doesn't. It's just standard software engineering and big data engineering here. And then using the ETL, we clean the data, then we do the basic analysis, then we apply the machine learning algorithm to do the predictive analytics, and then further we do the more optimization of the algorithms and utilizing deep learning and other tools in order to do a better prediction. So once we are done with training a model, coming up with a mental model, we move that model to the production. This model is essentially those rules created by the computer itself, which we loaded in production and then do the work. Now, when we move it to production, it could be in the form of, let's say we are launching a service which people will be calling, that's called REST API. Like for example, there are many kind of services today. Let's say service for doing the face recognition we built for, the one that we built, Deja Vu as an example. It could be building an Android app. Maybe we are doing the face recognition or any other machine learning on the phone itself. So then we have to move that model to the phone, or we have to build the mobile app, right? And next is that whether you are building a separate server or deploying it onto some other mechanisms, mostly there are two skills required at this point: either ability to build a mobile app, web app, or to do the DevOps. All right. So this is what we discussed. So this basically covers DevOps, deep learning, the machine learning engineers and data scientists, and the AI engineers and data analysts. Here the data analysts. Here the big data engineers come into play. Okay. Now, okay, so one of the things, okay, in case the screen is too blurred, try changing the resolution of YouTube. When YouTube detects that your connection is slow, it actually just changes the resolution to something else, right? So please use that in the settings. You have this option to changing it to the best possible. There you will be able to see this. All right. Now, great, wonderful to have so many people attending to this. I hope I'll be able to do justice with your time. Now, there are various kinds of career options today for everyone. So first one is a software engineer machine learning. So a software engineer in machine learning should know the computer science basics, should be able to apply machine learning algorithms and libraries, and should know the software engineering and system design. So these three parts they should know. Single tick means they should be aware of only the basics, so they can just apply and use an existing algorithm or existing model. They should be able to use it, right? Double tick means it's a person should have a good knowledge of the subject. Then the software engineer in big data should have basics of computer science good, and should have good, as in they should have only the basics of computer science, not like very detailed one. They should also know basics of software engineering and system design, but they should know the big data engineering very well. Okay. Then applied machine learning engineer should have their computer science basics really well, while data modeling and evaluation could be they should know just basics, and applied machine learning algorithms and libraries something they should know really well. And then they should also know basics of software engineering and system design, because they might have to deploy or keep their code backed up and so on. Now, the core machine learning engineer should know the computer science basics really well, They should know basics of probability and statistics. The data modeling and evaluation should be very thorough. They should be very thorough with applying machine learning algorithms. Data analysts should know basics of computer science, just the basics. Should be thorough with probability and statistics, and they should be thorough with data modeling and evaluation. In this particular course, we are aiming for these three positions, these four positions. We have a separate course that you can enroll. So IIT Roorkee, the deep learning specialization caters to these three, this and this. All right. Though for a data analyst position, this particular course will be just too much, but still you will be able to learn the basics of data modeling and evaluation, right? Now, I want to explain a little bit more about data science jobs. Data science jobs have increased. Data scientist has been called the sexiest job of the 21st century. There will be 11.6 million new jobs in next 6 years. Post COVID-19, everything will digitize faster, creating more job opportunities. While almost every industry has changed because of this pandemic, the digitization or digitalization of most of the organization has been forced by COVID-19 pandemic. And during this pandemic, lots of organization became more and more digital, more and more online than they were before. And hence it basically has created more and more opportunities in software engineering and machine learning. Lots of people are losing jobs. Lots of people are basically having their salaries trimmed down. And it is happening worldwide. But most of the AI machine learning jobs are still going to be being expected to grow this year and accelerate further. The software engineers engineers and AI and machine learning engineers are going to be still in the demand, while the other industries are not going to be that much in demand. Most of the information workers are going to be in demand as much as in the near future. So these jobs, the jobs in AI and machine learning are going to grow in spite of the pandemic. All right. So in the future of work, AI will dominate. Most of the jobs will become one way or another AI jobs, whether you are working as somebody who is gathering data or cleaning data or any of the component in that. I clearly told, as I told earlier, that most of the companies today, they do basically the prediction. Okay, so AI jobs will increase by 16% in 2020, and AI funding is going to be raised by 6.9 billion US dollars in the first quarter of 2020. And AI in automotive is going to be again very predominant. The automotive AI market will reach around 15.9 billion by 2027. AI growth is global. Chinese AI startups have raised 15 billion till 2019. UK AI startups have raised close to $4 billion. Okay, so basically you can see that the global trend in the future of work, that most of the jobs are going to be around AI and machine learning. Alright, there are multiple courses that CloudxLab offers. One of them is the Python one. Python and Linux are the fundamental basic courses that we expect everybody to learn. And the DevOps part is something to do with deploying as well as operating on the software components. So this course is something very groundbreaking. Lots of people are attending it right now as we talk. There is a class that is going on parallel, and the big data engineering is something that involves Hadoop and Spark. When your data is in terabytes, then you use these tools to do the processing of that data. And machine learning specialization deals with taking the data and coming up with the predictions, utilizing algorithms to do the predictions. And this course is, these two courses are self-paced. This one is also self-paced. This is self-paced. This is self-paced, while this is live. And data science is a composite of this course as well as this course. So both of these combine, where we learn about big data engineering using Hadoop and Spark. And here we learn about machine learning as well as deep learning. This is a self-paced course. So both of these combined together form our data science course. This data science course comes with ENICT certificate as well as only the certificate of CloudxLab. So you can pick any of those. So data science certification basically covers these two big components. And the AI and deep learning specialization course, the course that we have launched with IIT Roorkee, it is the new course, as in most of the it is the new course. It's going to be delivered by instructors from IIT Roorkee as well as experts from the industry. Again, this course is something in very high demand, and it got sold out very quickly. It got filled very quickly, 70% of the seats in first 10 days, and this is going really, really fast. So if you, but you have to apply for this eligibility for this course, and your profile as well as your submission will be reviewed, and then you will get the acceptance or rejection based on your submission. All right. So the purpose is that we are trying to figure out that it should not be a loss for you. Therefore, we have kept the enrollment bar little high. All right. So okay. So now I hope everybody is clear about what exactly is machine learning, what exactly is deep learning, and AI. Okay, AI is the objective, while machine learning is the suite of components. Deep learning is a part of machine learning. All right, deep learning is part of machine learning. This course is very much dedicated to deep learning, though we are going to cover the machine learning basics in this course. All right, so these are the main courses. So let me just walk you through this particular course. This is something that people have asked in the questions. So basically, this course is okay. So this course is around. This course basically starts with Python. I think I'll just walk you through the curriculum. That will be way better. Okay. So this course has Linux as self-paced in this part, and Python also as part of it. So it's a self-paced course. Again, statistical foundations are self-paced. So by the time the course starts, you can finish these self-paced components. And when the course starts, course will be starting from here. In the first session, we are going to learn the basics of what is machine learning, what are the various types of machine learning, and the foundation of the deep learning, how it works. Then afterwards, we will talk about the data. We will talk about in the next session, we will build we will build an end-to-end machine learning project. This is the chapter, not the session, because it's a big chapter, so it may not finish in one session. It might require multiple sessions. Everything, even if you are completely new to machine learning, I can assure you that by the time you finish this particular chapter, these two chapters, you will be very comfortable and you will be ready to be machine learning, the AI software engineer ML. We call them software engineer ML, meaning that they can start applying in their subject just after finishing these two chapters. After that, we go deep dive into classification, like how to do classification, because this is a part of the kind of machine learning called regression, where we predict the house pricing. Here we predict we do the OCR, as in predict the hand-drawn characters. Okay, we learn to train the machine to learn how to predict what is drawn, right? That is what we do as part of this particular chapter. Afterwards, we would cover the machine learning algorithms. Basically, we'll give the overview of all the algorithms, and it covers whatever is required in the other basic foundation part of the machine learning. So even if you are absolutely new to machine learning, these chapters will give you very good understanding of machine learning. Afterwards, from 8th chapter onwards, we start with neural networks. This is where the deep learning starts. So on chapter 8, we are starting with deep learning. On the chapter 4, we are starting with basic machine learning, while 1 to 3 are the foundation. These are the foundation that you will have to finish by yourself. Here the exercises as well as videos as well as text is provided to you, so you have to finish those. And if you've already finished those parts as part of our other courses, then you don't have to worry about it. Alright, then afterwards here you basically we start with neural network, and then we go into understanding the maths behind the neural network. So this chapter is something else. So even if you have been able to do this, understand this chapter, so though we assume that you have done basic high school maths, but still we will do a refresher here. Okay, so here we will do the TensorFlow 1, basically how to do the previous way. Here we will learn how to do, like, if you have to build everything from the scratch, and afterwards we'll learn to do TensorFlow 2, and from here we'll load the data. Then we'll do this is called computer vision. Computer vision is like face recognition and object recognition and other aspects of the image processing and so on. So this part is around the computer vision. The next one is around the sequences. Here we will also learn about the time series and other parts. So the RNNs and the RNNs and CNNs combined together are used in synthesizing music and so on. We will take those examples and show you how to do that. Also, to do the predictions in the stock market, we use this technique. We will show you with a sample data set how to do the prediction from the stock market. Afterwards, in this chapter, we will learn how to process the natural language. How does computer learn to process the English language? And you will be amazed to see that it understands the language more than you think it does. Alright, so those ideas we will learn here, so that you can apply the natural language processing, like building a bot, and all of that will be covered here. The science behind all of this, the high level APIs will be covered here. So these courses, while these are very deep dive, very hands-on, they're also fairly deep dive. And then in this one we talk about something called generative learning, whereby how does a computer learns to dream, for example, learns to synthesize images. Those are the things we will show you here. And This part, the last chapter, is around reinforcement learning. Reinforcement learning is the one that we showed you in the Mario example, whereby in this case we will learn how to build um, um, an agent which can play a game in the environment. So this is a very this topic involves multiple such topics that you study earlier, like it involves the RNNs, it involves the standard machine learning, deep learning, and so on. That's why this chapter is towards the end. So this one is something that mimics the human behavior. So we will learn how all of these concepts as part of this course, this particular course. Although some of these concepts are already covered in machine learning specialization, but this one is self-paced. Wonderful, wonderful set of questions. All right, we have 30 more minutes, and I'm going to answer the frequently asked questions from the chat as well as there is one question that has been asked multiple times, that IIT Roorkee provides a hard copy certificate or only digital copy. In case by the time of the certificate distribution, or we can say mini convocation, if the lockdown is over, we will have a ceremony at the campus. All right, whether Noida campus or Roorkee campus, either of the two campuses. So depends on the lockdown. So we will, those who are not able to come, we will send it. We will give you the digital copy, and we will see if we can ship you the hard copy as well. If you are international learner, so we'll try to ship you the hard copy as well. Okay, so it's that's something that we will try to do, but that depends on if the lockdown is over or not. But digital copy, the soft copy, will be provided to all. A question from someone is that, can you please elaborate on hiring opportunities you mentioned? Do you help in scheduling the interviews? Yes. So the way we are going to do with respect to hiring is that, one, we ourselves will conduct the basic discussions, basic interviews. We will have the candidates ready for the interviews, and based on your performance in the interviews with us, we will start we will be organizing the online placement drives. The most important part is that we will organize the online placement drives. Okay, in the online placement drives, the company or the recruiter, they will come online, they will basically shortlist the candidates, and then they will start interviewing the candidate. So this is something that we are working underneath while the course is being completed. We are tying up with various recruiters and the industry partners. And since our candidates in past, our learners in past have shown very good track record, people are inclined to hire from us, and this is something that is very different about CloudxLab as compared to any other institution, that most of our learners are well placed so far, and we are going to work very hard on the placement, and this is something that we are going to work towards. Again, we can only help you learn, but clearing the interview is on you. Okay, we will prepare you with the standard interview questions if you have doubts and so on, but clearing an interview would be up to you. All right, this is something I want to keep it very, very clear, that we wouldn't be, even if, let's say, we ourselves are hiring, most of our team is actually our learners. We trust our education, and we interview those candidates. We give the first priority to them, and even if we ourselves are hiring, we conduct our interviews, and we do not just look at the certificate and say let's hire them. No, I mean, even for that matter, even if you are holding the Harvard degree today, no company would actually hire you just based on certificate. Everybody would conduct the interviews. The only thing that differentiates a good college is that how many people are coming to hire from them. So that is something that we are working with. They want to hire from us because this particular skill is not that available. And the fact is that when lots of corporates are coming to us and asking us to train their people, those same corporates are also asking us that can you give us more candidates which they don't have to train. All right, so both education and the hiring goes hand in hand. All right, moving ahead. So that was the next question. I'm going to answer one more question. A question is, please explain working in each given career option. Okay. All right. Okay. Let me go back. Yeah, here. So, or let me go back here. This would be way better to explain. The question that I'm trying to answer is, please explain working in each career option. Okay, so if you are, let's say, DevOps engineer, your role will involve moving or let's say you are machine learning. If you are a machine learning, okay, let me just talk about AI first. So let's say you are from a background whereby you've done the big data engineering. So you will be working on this, or these three. If you are from the big data analytics or just data analytics background, you will be mostly working here. Okay, meaning given structured data, come up with the basic analysis. Okay, and that will be, find out how many what is the most frequent device used in our by our customers, what are the top 10 countries in which our app is popular. That is the basic analysis here that you'll have to do. Then here, when you use the ML algorithm here at this point of time, this is something to be done by AI engineers, ML engineers, software engineer, ML. This is something that they need to do. While a machine learning engineer would also have to do this. So basic software engineer, machine ML would have to know the engineering stack as well as little bit of machine learning and so on. So this is the other metrics that I have presented. Software engineer will basically focus more on building the software, such as a mobile app, such as a web app, and then using the ML algorithm from time to time, just calling the API and giving it data, train it, and then or load the model and predict it. So ML engineer will basically would deal more with pre-trained model as in the models that were trained by somebody else. While software engineering big data will focus more on the software engineering related to the big data. Like they should know how to transfer the data, how to unzip the data, how to upload, how to move, how to do basic analytics, as well as they should know how to do the processing using multiple computers. All right, so that is the role of the big data engineer. Like if given a data, if they have to just run a standard algorithm, they should know that part. The applied ML engineer would basically know how to apply machine learning algorithms, as well as the basics of computers should be really strong for them, and computer science basics should be really strong for them, and so on. So basically, the applied machine learning engineer will be somebody who will be training the models, looking at the problem, training the models, and once the model is done, they will basically hand over the models to the software engineer, who might deploy those or use them in their own code. The core machine learning engineer focuses more and more on optimizing the predictions of the model. They will basically look at whether they need to come up with more features, they need to optimize the existing approach, they need to come up with more what do you call the objective functions, and or they need to utilize new algorithm in order to come up with more insights. So the core ML engineers focus on that. Data analyst knows how to apply machine learning and so on, but they are not expected to do lots of engineering like deploying models and so on. Okay, I hope this gave you a clear perspective about the jobs in this market, right? All right, now let me also go on to, there are lots of questions asked by people in this webinar. One question was, I am a student and I want to become a machine learning engineer. What should I study? So my suggestion will be, you start with Python. You start with, this is one of the courses that we have. You start with Python for machine learning, and then you can move on to learning machine learning specialization, and then deep learning. So good news for you is that both of these two, like Python as well as deep learning, are included in this. Okay, so my strong suggestion will be that you're a student, you should start with, say, Linux and Python, and then the core machine learning, and then deep learning, and everything is included in this specialization. Okay. Again, let's say you are a student and you want to become a data scientist. What should I do? What should you study? You should go for data science specialization. It includes both the machine learning specialization as well as the big data. All right. Now, if you are somebody who is fresh out of college and want to become a DevOps engineer, what should you study? You should start with Python, Linux, and then go on to DevOps. And this career path we have already included in DevOps specialization, that it will include Python, Linux, and then all other tools such as Git and Docker and Ansible, and all those components are included in the DevOps. All right. So we have a course for that. Then if you are fresh out of college and you want to become a big data engineer, you should start with Linux, which is actually in here already. You should start with any programming language. Even Python is good. You can do the same thing in Python what you do with Scala. And Scala is generally a choice for the Spark. And once you are done with both, you should move on to learning Hadoop and then Spark. All of this is part of our data engineering course. Now, a question that is that I want to become a machine learning engineer. I would strongly suggest that go for either the machine learning specialization that is there on our website, or go for deep learning specialization that we have recently launched. Deep learning specialization that we have recently launched is a very aggressive course, and I can assure you that in the live classes you will be able to. In this case also, you should go for DevOps specialization. All right, I'm couple of questions. I'm moving ahead so that I can answer more of your questions, and these are questions that have been asked in past. So if you want to become data engineer, there is a course called Big Data with Hadoop and Spark. Let me just walk you through that. I think this will make more sense if I just walk you through here. Okay, right. So if you come here, the big data engineering with Hadoop and Spark, for example, or yeah, this one. So in this course is designed for those people who are trying to process humongous data. So it involves both science as well as the practical application of both, and it's a very huge course. Don't look at the prices and don't judge it based on the price. This is a very detailed course in which we cover the Hadoop part first. Okay, so Hadoop is generally used in the cases where you have terabytes of data and you would like to process that data, right, and make it a little more manageable so that you can feed it to the machine learning algorithms. So the Hadoop, it basically includes all the chapters that you would actually have in the in understanding the distributed computing. So this course that you see here, of the big data engineering, this is essentially a distributed computing course. What is distributed computing? In which we make the multiple computers do your work. All right. So it essentially involves understanding all the foundations and ideas about coordination between multiple computers, storing data on multiple computers, as well as running the program on multiple computers, as well as structuring your logic so that your sorting and other complex tasks can be executed on multiple computers, and you can do data analysis using multiple computers. As in, if you have, like for example, when I was at InMobi, I was processing 200 terabyte data. It was not possible using any tools that you know. It was only possible using Hadoop ecosystem because it utilized more than 800 computers simultaneously. So basically, when you have to utilize more computers simultaneously, this is the course that you must go through. And generally, those people who are trying to go for big data engineering course, and those who are comfortable with the basic engineering, they would really appreciate this course, and their industry value will be improved. And it also includes a second course. It is on Spark. Every part of the Spark is covered, including machine learning with the Spark. That much that you should know. All right. So that is the big data engineering course. It's a very detailed course, and we have taken many digressions in order to make the complex concepts easier to digest. If you have a non-technical background and you would like to learn AI and machine learning, I personally would recommend AI for Managers. This course came from my interaction with lots of thought leaders in industry, those who were not hands-on but they wanted to understand the ideas behind every algorithm. So this course, though it sounds like very high level from the caption of it, but this course is essentially understanding how the prediction works, how the mind works, how does mathematical model works in very simple language, without using any mathematical symbols, without assuming about your knowledge on many maths. This course is for those who are trying to understand machine learning and do not have technical background. This course is for them. And this course is something that has been very unique because very complex concepts, we have tried to convert them into something very easily digestible. A complex algorithm such as k-means or such as dimensionality reduction, we have tried to explain using very simple analogies. And most of the people who have attended this course have really appreciated it because they were able to understand how exactly the models are doing the predictions. So most of the videos prepared for this will be included in remaining courses, okay, because this one has been very foundational work, a unique work. It is not a just case study survey. No, it is a deep dive understanding of every algorithm. Even though it sounds like AI for Managers, the only difference with this course is that you would not have to learn any maths or programming for that matter in order to understand machine learning. This is a unique course. This is a very hard course that we did, and it's a recorded course, so you can attend at any point of time. Do I need a background in advanced maths to learn AI and ML? That's another question. No, just a high school level background in maths is adequate. That in case of, we are talking about the deep learning specialization course, any further maths required to learn AI ML will be taught as part of the course itself. All right. So the one that we are launching and the one that is coming up, it's a course on AI and deep learning. It's a specialization on deep learning by IIT Roorkee, and that's starting on 31st May. There are only few seats left, so please is from 7:30. The course is from 8 p.m. to 11 p.m. IST or 7:30 a.m. PST. Okay, so you can see this is the pricing here, and you can enroll for the course. I'll just copy paste the link in the comments. All right, so all right, please feel free to ask questions. I would love to answer a few more questions. Okay. All right. So the course page that the one that I have shared is the source of truth for everyone. The information on that course page is something that we are abiding by, and there is no other place of information that is more true than this page. A question from Alankrit Nayak is that, is there any reference book associated with the course? We usually follow a book called Hands-On with Scikit-learn by Aureline Geron. Okay. And you can take a look at it. I have not put its full name, but you can find it. Aureline Geron. It's a most popular book on Amazon, and I personally like the book very much. And since it very well gelled with the way we wanted to teach deep learning, we have picked up that book so that it is very much applied, hands-on for this particular course. It is very applied and hands-on, and we'll be using. All right. Is the course duration 45 hours? Yes. As per now, the course duration is 45 hours. The self-paced is not included in these hours. So as per our hypothesis, it should finish in 45 hours, but we are completely okay to extend it by 1 or 2 sessions if there are more doubts, if people want, if they want to study some more concepts in deep. We are open to that. All right, but the course duration as of now is 45 hours. A question is that, will the lectures be added freely on YouTube? Okay, that is very difficult to answer. This is something that we will have to consult with IIT. I'm not sure if it'll get approved, but if it gets approved, we would like to do that. Is the course helpful for more than 6 years of experienced person? Of course. This course is very useful. It has been proven useful for all the people, all the people from all kinds of ages, and you'll find a huge diversity in the class. You will find a person with couple of years of experience as well as person with decades of experience in the class. All right. What are the job prospects after completion of the course? We have seen we have seen that multiple people who have finished our machine learning course are well placed and have done very great in their career. Therefore, this course should definitely help you. And in this particular course, we will try our best to get everyone everyone placed, and this is something that we are working very aggressively. A question from Suresh is that I am a Java architect with 17 years experience. Will this course be useful to me? Of course. Because whatever you have learned, you will be able to augment this knowledge with that. So for example, since you are coming from Java background, in a organization, you will be able to do this part easily. You will be able to at least do this part easily, deploying and building application, as well as gathering data for you. Doing knowledge will come handy to you. All right. So okay, so we are going to let me just there are some people who are asking for the reference book. This is the reference book that we follow. Okay, it's going to show my personal preferences, but that's okay. The reference book we are going to follow are hands-on machine learning. Okay, this book. Okay, so this book is what we are going to follow in this course, though there are some concepts which are beyond this book, but for those books we will for those concepts we'll share with you the other idea. Okay, I'm not able to create a link. Let me just, okay, so let me just see if I can have a quick link. Okay, so I'll just share the link with all of you. Ouch. Okay, let me see if it gets copied or not. Okay, now it seems to be copied. It's not allowing me to copy paste that big URL. Alright, so this is the book that we are going to follow, and yes, the second version of it. Alright, we're going to follow the second version of it, and this is something, there will be a couple of more books that we will be following, that we will mention in the class. There is a book called Deep Learning that we will be sharing with you, the URL, and yeah, there are around 3 books that we are following in this course, but the majority is this one. Okay, so great, wonderful set of questions, and I'm really thankful that most of you have stayed back till the end, and yes, thank you, Ankur. That yeah, that's the book that we're going to follow, the Francois Squalet. That's the second book that we're going to follow. Yes. All right, wonderful set of questions, and feel free to reach out to us at any point of time. Okay, you can either write to us at discussion.cloudxlab.com, discuss.cloudxlab.com. That's the URL for our forum, or you can reach out to us at reachus@cloudxlab.com. Okay, if it's a technical question, come over to the discussion forum and ask there. If it's a non-technical question, it's related to buying the course or your account, do drop us an email at reachus@cloudxlab. Okay, one last question. I'm a test lead with 12 years of experience. Will this course will be helpful to grow? Yes. So good question. So there are number of things that you need to know about machine learning before testing machine learning algorithms, and the reason why why the testing of machine learning algorithm is way hard is because not many test engineers are not many test engineers are comfortable with the machine learning concepts. And and almost every project, this I saw at InMobi, for example, when we were doing the recommendation engine. First question our test lead asked me is that, hey, how am I going to test it? How am I going to test whether your engine is giving good predictions or bad predictions? So I had to basically explain to him and teach him the entire machine learning models. And I saw that those particular discussions were really useful for him, and he gave me a feedback that these the ideas that you should actually teach others as well in the team, and that worked out pretty well at InMobi. So even though most of the test engineers feel that their role is not engineering, but trust me, software engineers, basically the testing engineers or SDET are basically somebody who is a better software engineer. So I would say that whether you are in testing or in software development, knowing machine learning will broaden your horizon, will make you a better problem solver, will make you take up more projects, will give you the courage to pick up the larger problems to solve. All right, wonderful set of questions, and this is pretty much for today. We will post this webinar onto the YouTube. It is already posted actually, and the slides we will be sharing with you over the email. All those who had registered for this webinar will get the slides as well as the link to the YouTube video. All right, so thank you everyone, and have a good day. Thank you everyone for giving your 2 hours of time. All right, so thank you everyone for wonderful set of questions. All right, so thank you everyone I hope for wonderful set of questions. All right, so thank you everyone I hope for wonderful set of. Okay, I'm sorry for the echo. All right, so feel free to reach out to us at reachus at CloudxLab, or you join us at discuss.cloudxlab. All right. Again, thank you everyone. So I'll be stopping the streaming now, and the video will be available to you very soon.